Hello Geometry, this lesson is entitled Sine, Cosine, and Tangent Ratios. Well, what is one way to find side lengths in a right triangle? First, we've already learned that the Pythagorean theorem is a squared plus b squared equals c squared, and that allows us to find a third side of a right triangle if we already know two sides. Again, and the way I like to look at it is leg squared plus leg squared equals hypotenuse squared. Again, but when can you use that theorem? That theorem actually only works if you actually know two sides. So if I knew this was 4 and I knew this was 3, and let's call that x, I could use the Pythagorean theorem to find what x is. I would need to know the two sides. Well, what happens if you don't know two sides? Well, let's take a look at that. We have this here, this little diagram here. This is what we're going to use if you don't have two of the three sides. In this case, you're going to have one side length and one angle measure besides the 90 degrees, and that's going to help you find another side length. Well, here we have what we call trigonometric ratios. We have sine, cosine, and tangent. Now, we can only use these in right triangles, these ratios. Okay, so sine here says opposite leg over the hypotenuse leg. Now the key with this is it says sine A. That means we're going from this angle here, angle A. So the sine ratio is the opposite leg over the hypotenuse. So in this case, it would be little a over c. And that's why we can only use this in a right triangle, because notice it's opposite leg over hypotenuse, and by definition, hypotenuse is the side opposite a right angle in a right triangle. So, that is the sine ratio. Again, it's opposite of the angle you're talking about, the opposite leg, so in this case, lowercase a, over the hypotenuse. And by the way, a little side tangent here. We always use capital letters for angles, and we use lowercase for side lengths. Just a little tidbit for you. Alright, next it says the cosine. The cosine, again, of angle A. So from A, it says the adjacent leg. Now, you have two sides here. We have this one and we have this one making up angle A. So the question is, which one is adjacent? If adjacent means next to. Well, aren't they both next to it? Sure, but it says adjacent leg, so it's saying the adjacent leg that makes up the right angle. So from A, it would be this one right here. It would be B over the hypotenuse. That's some bad handwriting there. So again, adjacent, man, I can't write. Here we go. Over the hypotenuse, okay? B over C. And lastly, we have tangent, okay? Tangent here, again, from A, says it's your opposite leg over adjacent. So in this case, from angle A, your opposite is that little a over adjacent, which is the little b. Okay? Now the biggest thing to remember is that the ratio is all about from what angle you're talking about. So it's not always going to be A over C. It's not always for sine. It all depends on what angle you're going from. If I was going from angle B, if I was looking for the sine of angle B, the opposite, notice, is B over the hypotenuse C. So again, it all depends on from what angle you're going from. Alright, now let's take a look here. Write the tangent ratios for angle T and angle U. So what this is saying is when we write out tangent, we're saying tangent of an angle, sine of an angle, cosine of an angle. So in this case, this is how we're going to write this out. Notation-wise, we say the tangent of angle T is equal to opposite. Well, again, from T, opposite is 3, over the adjacent, which is going to be 4. Tangent U, so tan, capital U, again, angles are capital, is equal to opposite from U, which is 4, over the adjacent, again. From U, opposite is going to be the 4. Alright? Let's look at another problem. Write the tangent ratios for angle K and angle J. So we'll call this part A. The tangent of angle K. So from K, the opposite is 3, the adjacent is 7. But from angle J, the ratio from J, opposite is 7, the adjacent is 3. Okay? Now, it says, how is tan K and tan related to tan J? If you notice, if you look at both of them, you would see that their answers, or their ratios, are reciprocals of each other. Okay? 3/7, 7/3. Okay? So the tangent from those two angles will always be reciprocals of each other. Alright, let's look at another one. Okay, now comes where we're going to actually have to apply. We have to come up with equations and solve them. Now, before you do these, we're going to be plugging these values into our calculator. It's vital that you look at your calculator, and if it's a TI-84 or something like that, what you want to do is hit the button that says mode. Okay, you want to hit mode, and your third one down, it should be the third one down, has two options, radian or degree. You have to make sure your calculator is highlighted on the degree. Has to be in degree mode, not radian. Make sure it's in degree mode before you do any of these problems, okay? Again, degree mode, not radians. Okay, now we can get to this problem. Now our calculators are in the right mode. It says find the value of W to the nearest tenth. So what we're going to end up doing is setting up an equation to solve for W by using a trigonometric ratio. Well, if you look at the 54, the angle 54, we are looking for W, and in this case, from the 54, that would be your opposite leg. And the side that we know is the 10, and that would be your adjacent leg. Well, what is opposite over adjacent? Well, that's tangent. So we can set up our equation and say the tangent of 54 degrees is equal to opposite, which is W, over adjacent, which is 10. Okay? But now we still have to solve for W, so what you do is, how do you get the 10 out of the bottom? Well, if you just multiply it by 10, they just cancel right out, which you're allowed to do as long as you multiply the other side by 10 as well. Whatever you do to one side, you got to do to the other. So now, if you were to type in that to your calculator, 10 times the tangent of 54, you would get about 13.8. Again, round to the nearest tenth. I got 13.76, but that ends up rounding it to 13.8. So again, the key here is to figure out what side you're looking for, what side do you know. Now, this next one. Notice from the 28, the opposite is 1, the adjacent is W. Now, there's a temptation to always put the variable on top, but you have to stick to the ratio. So in this case, the tangent of 28 degrees, actually let me move that over a little bit. The tangent of 28 degrees is equal to opposite 1 over adjacent, which is W. Okay, but notice W is in the denominator now, so what do you do? Well, when you have two numbers on opposite sides of the equal sign, especially with fractions, you are allowed to switch places diagonally across an equal sign. It's kind of like the whole cross multiply thing. So, we're going to swap the W and the tangent of 28. Notice again that tan 28 is in the denominator. So when you go to your calculator, you're going to type in 1 divided by the tangent of 28. And we get about 1.9. Okay? So again, sometimes the variable is going to be a denominator. So what you do, you switch spots diagonally, so the tangent swings down underneath the 1, and we type it in how we see it, 1 divided by tangent of 28. Alright, let's do one more here. Alright, now we have here W. Now we know both angles. We know the 57, we know the 33. So we technically could use either one we want. Well, if that's the case, then I really like having my variable on top to begin with. So that my two sides are w over 2.5. So the question is, w is opposite which angle? So if it's opposite over adjacent, I need to make sure w is the opposite. So it's opposite the tangent. You know what? I'm just going to erase some of this to make a little bit more room here. It's opposite the 57. Okay? So the tangent of 57 is equal to opposite w over adjacent 2.5. But like we did on the other problems, we multiply by 2.5 to cancel that out. So here we have 2.5 times the tangent of 57. So if you work that out, tangent 2.5 times tan 57, we get w is equal to 3.8. Okay? Again, so that's how we deal with setting up these equations. You have to make sure you stick to the ratio. Tangent is opposite over adjacent. Alright. Now, let's switch it up a little bit here. It says the length of the sides of this triangle are given. Well, notice we actually know all three sides now. So what are we actually looking for? It says find the measurement of angle x. So we're looking for the angle degree on this one. Okay? Well, whenever you're looking for an angle measurement, you're going to use what we call an inverse button. So there's three buttons that show up on the calculator. There's this one, sine, inverse cosine, and inverse tangent. Okay, you use these buttons when you're looking for an angle measure. If you were looking for a side length, you would use the normal version, like regular sine. But in this case, we're looking for an angle measure, so we're going to use the inverse. So, technically, we can use any one we want, and I'll show you that actually all three work. So, if you were to do the inverse sine, what you're going to do is you're actually going to put your ratio in front of the inverse sine, not the angle measure. So, the inverse sine from x, and notice we're going to go from x on all of these. Sine is opposite over hypotenuse, so opposite x would be 6, the hypotenuse would be 10. So if we actually work that out, we would do inverse sine of 6 over 10 to the nearest degree. That gives us 37 degrees. Now let's go ahead and do cosine. The inverse cosine, again, from x, is adjacent, 8, over hypotenuse, 10. And if you do the inverse cosine of 8 over 10, you end up with 37 degrees. Look how that worked out. And lastly, let's do tangent. The inverse tangent from x of opposite 6 over adjacent 8 is equal to inverse tangent of 6 over 8, 37 degrees. So now we can go ahead and say that the measurement of angle x is equal to 37 degrees. Now you don't have to do all three in order to find it. I was just trying to show you that if you do any of these three, we're going to end up with the same answer. They all end up the same if you do it correctly. That's if you already know all three sides. Okay? Here it says find the measurement of angle y to the nearest degree. So again, we're looking for y. But here we don't have all three sides, so it's very important that we choose the correct trig ratio. Well, from y we know 141. Well, 100 is opposite and 41 is adjacent. So the trig ratio, opposite over adjacent, is tangent. So we're going to want to use inverse tangent on this one. Sine and cosine wouldn't work with the information we're given. We would have to use tangent because, again, it's opposite 100 over adjacent, which is 41. So when I type that into my calculator, inverse tangent of 100 over 41, I get it to the nearest degree, 68 degrees. Okay? So it's vital that you think about what sides do I know in comparison or in regards to the angle that I'm looking at. Okay? use the triangle to write each ratio. Sine. So sine from t. Let's get a little practice with sine cosine here. From t, again, sine is opposite over hypotenuse. So in this case, it's just 8 over hypotenuse, 17. How about the cosine of t? Well, the cosine is adjacent, so the leg adjacent to t is 15 over the hypotenuse of 17. Sine of g, again, sine of g, opposite from g is 15 over the hypotenuse, which is 17. And then cosine of g is adjacent, 8 over 17. Not sure if you notice here, but notice these two are the same and those two are the same. So the sine of one angle, t, is equal to the cosine of the other, and vice versa. Cosine of t is equal to the sine of g. So just something to keep in mind is that if you know the sine from one angle, you know the cosine from the other angle. Alright. Now here it says write the sine and cosine ratios of angle x and angle y. So here let's start off with x. Sine x from x is going to give us opposite 64 over adjacent 80. And always reduce if you can. So notice that 64 over 80 reduces. The number 16 actually goes into both of those. So this reduces to 4 over 5. Now the cosine of x is equal to 48 over 80. And 16 goes into both of those as well, and so that gives us 3/5. Now, like I said in my last example, is that the sine of one of them is equal to the cosine of the other angle. So we don't even have to, you would technically not even have to look at the numbers on the triangle again to find the sine of y and the cosine of y, because what I do is I take the cosine of x and say that's the same thing as sine of y. So I know that's going to be 3/5. And likewise, the cosine of y, I get that from the sine of x, which is 4/5. Now it says here, on part B it says, when does sine x equals cosine y? And again, we said that is always going to be the case. Okay? The sine of one will equal the cosine of the other on these type of triangles. Okay? Again, always. Alright. Let's just do a couple more here. Find the measurement of angle L to the nearest degree. So, we have all three sides, so we get to choose. But we've already done a tangent one, so let's go ahead and do a sine. So, from L, if we wanted to use sine, so if we're looking for an angle measure, we're going to use the inverse sine. So, opposite L gives me 3.2. The hypotenuse is 4. So when I type that in my calculator, sine of 3.2 over 4 to the nearest degree, I see that the measurement of angle L is equal to 53 degrees. Okay? So again, you could have done inverse cosine of L. You could have done inverse tangent. I just chose to go with inverse sine. But you should get the same answer on all three if you do it correctly. Okay? Now here it says find the value of x, round your answer to the nearest degree. So again, it's so important that you figure out which one is the right one. So on A, from x, you see that we have the opposite and we have the hypotenuse. Opposite over hypotenuse is sine. So we would say the inverse sine, since we're looking for an angle measure, of 6.5 over 10. Inverse sine of 6.5 over 10 gives us about 41 degrees. Okay, if you did that correctly with me. Now on part B, notice the 10 is adjacent to x and 27 is the hypotenuse. So in that case, we would want to do inverse cosine. Adjacent over hypotenuse. If you did inverse cosine of 10 over 27, you should have got 68 degrees. Alright. let's do this last one. I wrote this one out. As you can see, it's not perfectly drawn. Find the value of x and y. Not drawn to scale. If anything, that 31's in the wrong spot. That should be up in the other angle, but right now that doesn't matter. So, we have find the value of x and y. Well, from the 31, if you wanted to solve for x, notice it's opposite, and we know the 12 is the hypotenuse, so that would be the sine. But we're looking for side lengths, so we're not going to use the inverse. So we're going to say the sine of 31 degrees is equal to opposite over hypotenuse. Okay, we set up that equation, and now we need to get the 12 out of there, which we can do by multiplying, as long as we do the same thing on the other side. So we have 12 sine of 31, we get x is equal to 6.2. Now if we want to solve from y, from the 31, well notice y is adjacent, so we would say the cosine of 31 is equal to adjacent over hypotenuse. So therefore we multiply, boom, multiply, and we go 12 cosine of 31, and if you did this correctly, you should have got 10.3. So again, it's very, very, very important to think from that angle that I know, where am I going? Opposite, adjacent, hypotenuse, where am I going? Because that changes which trig ratio you can use. Well, I hope that helps, and good luck.